Hi and welcome to my AGK tutorial. AGK stands for App Game Kit, and it is a programming language released by the game creators that allows you to write one source code and then deploy that source code on multiple platforms. Currently, with the Community Edition released in on the 15th of August 2011, the supported platforms include Windows, Mac OS, Samsung Spada, MeeGo, and of course Apple's iOS. So the idea is that you write your source code once and you can deploy it even to all those platforms. The tier 1, there are two stages. There's tier 1, which is a basic style code, or there's tier 2, which basically allows you to take AGK into those other platforms SDKs using their own software development kits. We're going to use tier 1 because it's the easiest to code with and the most accessible to all, because the compiler and the IDE and everything is basically set up and ready for us to go straight off the bat. I'm going to base this tutorial on a game I'm developing myself, hopefully for commercial release one day. It needs a bit more work before I'm ready to go that far, but it's a basic working game now and will teach you the basics you need to get started with your own projects. And we're going to start off, of course, by creating a new project. And we do this by opening up the IDE, clicking on File, New, and click on File, New, and but New Project. So we click on project there and give it a name. Now you'll notice that there's 3 templates provided for us already. I'm going to select the landscape template. It really doesn't matter. You can select generic or portrait as well. I'm going to be adjusting the settings myself manually anyway. So we're going to click on go. And then we're going to click on next, and we're going to give it a project title. Now I'm calling my project Scribble Squash. So that is a copyrighted name, so don't go nicking it, please. So Scribble, I can't spell it. So there we go, we've typed in my project name, so Scribble Squash, all one word. And we'll click on finish. No, I don't click on that, sorry. You see a resulting file name here. Now you want to copy this. I'll show you why in a moment. So if I just highlight the directory, you don't need the file name, click on copy and then click on finish. And this will then populate our project with the main and setup source code that we're going to start with. Now the first thing I need to do is prepare my folder with the media I'm going to load, and I'm just going to quickly take you through the media content I've generated. So you saw me copy the address of the project earlier, so if I open up a new folder I can then just paste it in here, providing my control key works. There we go. And that will then take you to the main project folder. Now the folder we want is going to be called media, and that hasn't been created yet, so I'm showing you this project just after it's been created. We need to compile the project once to get everything we need. So if you double click on main, you're already given some basic source code. So if we click on this button up here, compile, run and broadcast. Broadcast has to do with the app players that you can get on MeeGo and the Bada stores. Basically it allows you to broadcast the source code directly to a device, so you don't have to compile it for each device and then test it each time. It will just broadcast over and you can test it that way, see what it looks like and change all the settings. So I don't have any other devices here, I'm just using Windows for now. So if we click on compile, run and broadcast, you'll notice now that folder's popped up. We've got media and we've got the exe. So it's created a media file for us. It's also created a BYC file there. And we've got Scribble Squash, the exe here. If we go here, we've got the standard obligatory Hello World setup. Now, first of all, what I'm going to do is prepare my project by adjusting the setup settings. And first of all, I'm going to rename this. So I'm going to rename this Scribble. I keep forgetting the name of my own project. How embarrassing is that? Scribble Squash, sorry. So that's the name that will appear in the top window. So when we compile it, we're also going to adjust the the size of the window. Now I'm going to be working with netbooks and netbook style machines. Now iPad uses a standard resolution of 1024 by 768. However, most other devices in the netbook class and tablet series go for 1024 times 600. So in order to be as compatible as I can and go into as many platforms as I can, I'm going to initially start my project off aiming for all those other devices that support 1024 by 600. Also, because my media is sized to that, my specific sprites and images are created using that resolution as well. So if I, which isn't a problem, if I want to deploy it on iPad later on, all I need to do is adjust these settings again, adjust the media content so it looks nice, and that's all I need to do. Though you could deploy it on an iPad as is. You don't need to do all that. All that would happen is you would get some bars up and down. So it'd be like watching a movie on your iPad in widescreen. You'll just get an area of black up and down the program. But again, you don't have to do it that way. You can compile a specific version for the iPad as well if you wish. So the width of this is going to be 1024 and the height is going to be 600. Now I want it to be in full screen. However, I'm going to leave it as windowed for my video capturing purposes, because I'm only capturing at 1280 by 720. It's going to be easy if I put it in a window format for the screen capture software to work. I'm not entirely sure how it's going to cope with the whole thing swapping over to full screen, and at the very least it's just not going to capture all of it because it's capturing to the top of the screen instead of the center. So anyway, I'm going to leave it as window, but if you change that to 1, that will basically allow a full screen mode, so it won't be framed or anything. And you can just carry on from there. That's how I intend the game to be on netbooks anyway. So now that that's all set up, we'll go to main. Now the other thing I do to organize my source code, and I've been doing this through Dark Basic Professional for years, is breaking my source code up into multiple source code files. Shorter files means it's easier to find things, and with nice logical names like main loop, media, menu and game settings, it's easier to know where everything is, I find. So we're going to get rid of all this now, and we're going to add those 1, 2, 3, 4 files, and we do this by clicking on File, New and Empty File. Click on Yes, and then we'll give our file a name. So give them nice logical names like main loop, and this will contain all the subroutines I need relating to the main loop. So main loop.agc, click on save. It will appear up there and it will appear down here. Now these exclamation marks here basically means the files haven't been saved. So if we click on save all, those exclamation marks disappear, and that's all right. You'll also notice that here you've got a green bar going up and down the editor. Now if you type in anything here like that, it turns yellow. That basically means it has been saved. So if I then click on save, they turn green, and that basically means the data has been saved to the file. So if we go back to main and file, new and empty file again, click on yes, and the next one is going to be main loop and game settings.agc, and we're going to do another one as well, and we're going to call that media.agc, and we're going to add one final one, which is going to be, I've done game settings, loops, media and menu. Whoops, didn't want to do that. Whoops. Let's try again. Yes, and menu.agc, and that's our source codes basically set up. Now that's not all you need to do to get these source codes to be noticed. Why have I got an untitled there? No, I don't. Just check. So main, setup, loop, parameters. I think that's everything I need. So I don't know why I've got an untitled there. I must have clicked on something wrong and not noticed. So anyway, if we go to our main, now this has to be declared in the main file. If you declare anything else, it won't necessarily be included. So whenever you include source code files, it's best to do it first in your program. At least that's what I'm used to in C++, so I'm going to assume the same rules apply here. And it's good common sense anyway, because if you go to the front of the program, you want to see where all the source code is coming in from. So if you type in include and type in the source code names, you'll notice it's quite handily provided us with a second quote there as well. So main loop.agc and include game settings.agc and include media.agc, and the final one, include menu.agc. Doesn't matter which order you load these up in, as long as they are loaded up. Now we can briefly test our program to make sure it's working, and it will basically end. So there's no compile errors there, so we've just established that it's able to find all the file names and stuff, and there's no problems there. So remember to save regularly. That's a big must in programming. Now what I'm going to do now is create a user data type. Now what user data types basically do is attach themselves to variables with extensions. So it allows you to use a single identifier attached to a variable and give it multiple purposes. So I'll show you exactly what I mean. If I type in type underscore obj and then end type, so I don't forget. And now I always put a tab here because it allows you to read the code more easily. Now what I'm doing here is I'm creating a set of extensions or set of types. Should be SPR, sorry. So that's short for sprite. There we go. I'm just going to type all these and I'll explain exactly what they are. Now, there are three primary types of variables in BASIC and in AGK. This is integer, float, and string. Now an integer is a whole number. That means it can be 0, 1, 2, 3, 4, 5. A float is a bit number, so it can be 0.1, 0.2, 0.3, 0.4. There are additional things you need to know about it if you're going to go into deep, very, very precise variables, but for the level we're going here, the smallest number we're going to pick is 0.05, so we don't need to worry about that. All we need to know at this point is that floats are signaled by this symbol here, which is the hash key. So it immediately assumes anything without a hash or a dollar sign. So if I put a dollar sign here, for example, that would then be a string. Anything with a hash is then a float. Anything without either is an integer. Now a string is a string of characters. So that can be anything you like, and it's not handled in a mathematical way. For example, you can't add A and A. Well, actually you could, but instead of adding the values of A, it would add A and A together, so it would be A plus A would be AA rather than the value of A and A. But we're going to more about the math and stuff later on. So for all you need to know at the moment is three types: integer, float, string. String is a string of characters. Float is a bit number, and string is a integer is a whole number. And if we then go type again, we're going to create one more type for media. This will make more sense as we go along in the program. Probably not making much sense at the moment. So end type there, and I'm just going to have two pieces of media, theme and ball. Now I'm setting up this particular data type not because it's particularly useful, but because after I do this tutorial I intend to further develop this software and make it into a fully fledged game that I will probably sell online, or at least attempt to. So this is going to be a project I intend to sell in the future. So if you want to create a similar game, I don't have any problems with that. All I ask is that you use your own graphics, and of course you change the name so you don't use Scribble Squash. So we've done that, and we've programmed all this in. So that's basically our user data type setup. Now there's one thing I forgot to do. If I go back here into our project folder, and remember I mentioned the media folder, and that was created when we compiled the program. At the time I should have copied my media in there at once. So here's all the media I've created so far. We're just going to highlight this, and we're going to copy it into our media folder there. And what this basically does is you must note that all media must be in the media folder or a subfolder of the media folder. If you put it in the main root folder, the media won't be detected and it won't load. So it assumes that any file name, if you don't put in a specific extension, will be under the a specific file path will be located under the media folder. So I'll go into more on that as we go through. So you don't need to take all this in one go. So anyway, we've put all our media here. What I'm going to do is I'm going to carry on with the variables for a second, then I'll come back and I'll show you the media that I've included, and we'll discuss that. So we've created our data types here, and now we're going to set up our main variables. Now, another thing that is very, very important to remember is if you want your variable to be global, then it must be specified in the main.agc. You cannot specify it in any of these in any of these other files here. So main loop, setup, game settings, media, menu. Don't start declaring your globals here if you want it to be global. And by global we means it's a identifier that can be called from any part in the program. So no matter where you are, no matter what file you're using or what place in the program you are, whether it's a function, subroutine or whatever, again I'll go into more on this later, then you will be able to see it. Now, if I was to create it in there and call it, in here, and then create it with a subroutine, then go to it with a subroutine, then it will be treated as a local for that particular source code file, as I understand it. Now, you're welcome to experiment and see what you can get away with. Heavens forbid, I do that all the time. So it's always a good idea to see what the boundaries are and run little experiments and learn that sort of thing. So we're going to save the file there, and I'm just going to create my globals. Now, you don't type in global. Those of you who are coming from Dart Basic Professional, you do not need to type in global here. As long as it's under the main.agc, it's treated as a global. So background as obj. Now, what this basically does is we've got an identifier here called background, and we've assigned it to this data type. Now, what that basically does is give that identifier a series of extensions. So if I want to find out the image number associated with the object background, then all I do is type in background.img, and that will call up the information being stored within that variable. So obviously it could only be an integer. If I wanted to find out the x position of it, then I would use that, and that will call up a float. So that's how you use it. These are basically a set of extensions. It's almost like a file name. If you treat the identifier as a single file name, and you've got lots of different extensions, then each of those will hold a unique piece of data. But what this basically means is if I was going to create all these variables manually, it will be background.x, background img, and you'll have to carry on going like that. All I've basically done is eliminated the fact that I've eliminated the fact that I have to type in all this for each one. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 identifiers I'm going to be setting up. That will be 12 times this. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Assuming I had to use all these extensions, that will be 120 lines of code I have to type in. By doing this, all we're doing is we're typing in this lot once, we're assigning it to a particular type, and then we don't need to worry about it again. We simply refer to it by the type or by the dot extension. So logo as object, agk as object. In fact, I can speed things up a bit here by copying this, and I can just go legal tap court pad font music and sound. Now if I go back up here and go paste, 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 paste. Now for this is going to be media, so I'm going to change that to media, and one more. And there we go. So we basically created 120 lines of code effectively in what? 1, 2, 3, 4, 5, 6, 7, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 22, about 22 lines of code, and now substituting for 120 lines. So I think we'll agree that's a lot more efficient. Now, when I design a program, there are several ways of going about it if you want to be organized. You can create a design document, you can create it in pseudocode, you can create it in flowcharts, or you can do what I'm doing, which is basically mapping out your program by using subroutines and functions that you're going to fill in the details later. So if you close your eyes and you think, right, what do I need to do to make this game work? Well, first of all, we need to establish the game settings. Now, instead of using functions, which are basically substitute commands that you can repeatedly use, now there's nothing I really need to repeatedly use in this program. So I'm going to be using subroutines instead, and I'm going to be designing them using subroutines. So if I go sub game settings, then basically what will happen here is game settings will be called. Now, we haven't created game settings yet, so let's see how we go about creating a subroutine. Now, game settings would naturally be under the game settings files. So if I type in game settings, did I put capital settings? That's right. And we type in return. Now, if we just put in a little bit of sample text, just do sync and loop, and we'll just put in a quick print. This works. Hopefully it does, and it won't embarrass me horribly. So anyway, we created a little program there within our loop. So yes, we've created a subroutine here, which we've called. So basically, when this subroutine is hit, it then looks for the name that we've established under this file, which is game settings. It then executes these commands, and when it hits return, it will then return to our main program. Now, this one is going to be an infinite loop because I've used do and loop, which I'll explain later. But if we compile our program now, as you can say, even though it's under the game settings file, because we've included it at the beginning of our source code and we've listed the label, then the go sub will basically go to it. You can also use goto, which will basically do the same thing. However, goto doesn't obey the return symbol, so you'd have to go to another label, and it gets very messy. So go sub is a far neater way of doing it, and basically it just runs as if it was as if it had been typed into the main program. But again, if we compile it, just show that go2 works. I'm not entirely sure. Yes, it does. Make sure what I'm saying is actually right. So yes, we're going to replace that with go sub. And just to demonstrate what I mean, I'm also going to create the second one, which is go sub environment setup. And we're going to make a slight change here. We're going to just do a print. We're going to get rid of all this here. We just want to do a basic print. And we're going to then create another subroutine, which is going to be environment setup return, and we're going to type in print this works too, and that will basically be it. And we're going to put in sync here. Sync basically forces the application to draw everything to the screen, and we're going to just go sleep for 10 seconds, and we'll run the. Oh, what have I done here? Could not understand command at line 8 inside game settings. So what have I typed in wrong? I haven't put brackets around it. I think that's what I did wrong. There we go. So as you say, it's now using both those subroutines. So we got this works and this works too, and it's basically waiting, so I can't actually move it because the program just freezes and it waits and it does nothing. So anyway, both those worked. So we're basically going to both these subroutines, and it's basically going to another block of code held outside of the main program. So we're going to get rid of those. Now, the thing I threatened to do was show you the media content I've generated for this particular game. So excuse the creaking seat. So anyway, this is the media I've created. First of all, we've got AGK. Now, in my last tutorial, I told you that in order to comply with the distribution rights, you have to include the App Game Kit logo and somewhere in there saying this was created with the App Game Kit. You don't need to do this. The rules have changed. Both Mike and Lee have confirmed this to me, so I'm going to leave the App Game logo in there. I'm proud to use their software. I'm happy to announce it to the world and generate them some more business. It's a very easy kit to use, and were you doing this in C++ and God knows what else, you would be here a lot longer than you will be for this tutorial. So, it saves you a lot of work, show your appreciation, and throw in the logo, but again, you don't have to if you don't want to. So anyway, that's the logo that came with it. Now, if you want these logos, you can obtain it from the help file by clicking on help, and then click on distribution. Again, it gives you notices and that kind of thing, but you can ignore that. The rules have changed. If you want to download the logo kit, that will give you every resolution from 64 by 64 all the way up to 512, so that'll be 128, 256 as well. So they'll give you all of them, and you get white and you get black ones, so you can choose whichever one you particularly want. So anyway, that's that. Now, I'm also going to be using a background for most of this. I'm going to use, it's called Scribble Squash, because it's a Pong/squash style game that's made up with scribbles. So we're going to be using an A4 sheet of paper. I've put in some sort of Tipex effect up here. This is all done using various software apps on the iPad, actually. I drew all this on the iPad, and so that's the background we're going to be using for our main game. We've got the ball here, which is kind of a biro style ball. It's as if you took a blue biro pen and scribbled on the page, and that's what you're going to be batting back and forth. You've got the ball dot wave sound here. That's going to be the sound effect of the ball hitting the edge or the pad of the screen. We've got the chord effect here. Now, this is an overlay. Now, note all these images are PNG. PNG come with their own file transparency. Providing you set it up with your image editor, then basically the alpha channel is already included. So even though it looks white all around here, all you'll actually see when you bring it into the game are these red lines, which will overlay any background. This allows me to use the sheet of paper as a general background throughout the game, and then add different levels as well. Now, I could add additional quart styles as well. I could have it in blue pen, I could have it in circles, I could do numerous different styles, and I could basically just overlay it on that main background image, and I can even put in multiple background images if I want. So you can add as much variety as you want to code into the game. Now, I'm keeping it quite simple because it is a tutorial. Now, the next one I'm using is a font. This is what is called a font image or a bitmap font. Bitmap tools are what I use to generate this. I also designed my own particular font, so this is all hand drawn by myself. The rules are this is a 1024 by 386 resolution, or is it 384? I can't remember. 384, I do apologise. So basically, anyway, it's 16. It's a grid of 16 down by 6. So you got 16 letters across, and you got 6 rows, and each of these blocks is 64 by 64 pixels, which the software automatically detects. So if the image was half this size, then basically you lose some quality in your font. So the bigger the file, the better quality and the more you can reduce it. I recommend you put in a bigger one because it's always better to go to the size of the actual text in reality than it is to stretch it out. If you start stretching things out, it does start to look blurry and it does lose a lot of its detail. Now I'm actually cheating here. This is a font that is set up for white. If you provide a white font, which you should, this allows you to use the set text color command to color it to whatever you want. Now I'm only going to be using a blue sort of biro style font, so I also created one called font dark blue. It's a little bit lighter than I intended, but it does a good job in the game itself. By coloring it in myself, basically if I apply any of the color commands to this, that will be added in addition to the color that's already there. So if you want to set this up as red, then it would end up being red and blue mixed together, so God knows what you'll end up with. But because I'm only going to stick with the one color for this font, I'm just using a colored bitmap font which I'll load into the game, and that saves me having to set the color font text and from white to whatever. So it saves me a little bit of time because I know I'm only going to be using the one font. But again, if you want to use multiple colors, use the white one, and once you use the white one, you can adjust the colour within the program itself. This is going to be the music file, so halfbit.mp3. This was provided by Kevin McLeod. This is a Creative Commons licensed. It's licensed for commercial use, and you can even edit it. You can find it on their website, which I've put into the file here. So if you go to www.computex.com/m/c/royalty free, then basically it will provide you with a bunch of free stuff you can use. Now the only stipulation is that you've got to mention where you got it from, who you got it from, and who the copyright belongs to. So even if you base your music on it, you still need to mention the person's name, and if you do that, then you're legally covered by it. So the name and all other artwork was done by me, so that is my legal copyright. So anyone taking it without my permission is basically breaking the law. So anyway, so we got the legal there, we got the logo here. This is going to be the logo squash. Now I've separated all this into separate images because I'm going to treat them as separate sprites and position them manually. This Scribble Squash logo is when it when the game loads up initially, it's going to go to the screen. Then this Scribble Squash is going to move upwards slightly to give a little bit of animation, and tap screen to continue is basically going to appear below that. So it makes it look a bit nicer and a little bit more professional. We've got the pad here. This is the actual pad we're going to be using. This will be moving around our A4 sheet and batting our ball around. Again, it's PNG, so it's the alpha's sorted out. It basically means as I move this over the page, as I move over lines and other obstacles and stuff, it will basically show through this logo. So this white space in here isn't drawn in. It's all alphaed, and if you move it over a line or the court or whatever, you'll be able to see bits of red or bits of grey or whatever through it. So again, a little bit nicer. And we got the final one, which is basically tap the screen to start. Now I could have done all this text in a bitmap font, but I wanted to have a single image because I'm not going to be manipulating individual characters or anything like that. I'm just going to be loading up the sprite. It will be displayed. It might move up and down a bit, but that's going to be the limit of what I intend to do with it. So this makes it a lot easier, and it'll just be loading it in as an object, created as a sprite, placed on the screen, and that's the end that's all I need to worry about. So we've had a look at the media we're going to be loading. So what we're going to do now is we're going to carry on with the basic structure of our program. So I will explain all this once I've typed it all in. So go sub load music. I mean, they're all quite logical names. Go sub load sounds. Go sub load images. You need to be consistent, because if you call the wrong name, then the command's not going to work. So go sub images create sprites, go sub set sprite properties. They're nice self-explanatory names. That helps you keep track of the program. Set up text, go sub menu, and then we're going to go on to the main program loop. So we're going to type in do sync and loop, and we're going to right, the actual program itself is quite simple. So go sub wall detection, go sub detect collision, go sub update pad, go sub update ball, and go sub lives check. Now I'll explain the basic flow of the program. So we're going to start off, we're going to load the game settings, we're going to set up the program environment, we're going to load the music, we're going to load the sounds, and we're going to load the images. I'm loading the music first because I'm also going to include a play command. So basically, as the user sees a white screen for a brief moment while it's loading up the other media, the music is already playing, so they know the program is working. Then we're going to assign those images to sprites. We're going to set up the properties to those sprites. We're going to set up the text objects in the screen, in the game, and then we're going to go to our main menu because all the media is ready and all the media is ready and loaded and ready to go. Then we're going to go to our main game. Now do and loop. This basically creates an infinite cycle. So you start at do, you go to loop, you go to do, you go to loop, you go to do, you go to loop, and you execute everything that's in between. This is a loop that is designed not to be broken, though you can do it with the exit command, I believe, which will exit the loop for you. So if you do need to, for whatever reason, you can use that command. But for my purposes, it's just going to be an infinite loop that goes on forever and ever and ever until the game is basically ended. So the sync command is used to draw data to the screen. I will go into more on that when I go into the environment settings. So first of all, what we're going to do is we're going to comment all of this, and we comment by putting in double slashes. When text turns up green with double slashes like that, it basically means it's a comment, therefore it's ignored by the compiler and has no effect on your final game. So if we go now we can activate these one at a time as we go through our program. So again, I'm just going to quickly compile, see if it throws up any error messages. No, it doesn't. So basically the program is running now and it's just going in an infinite loop while doing nothing. So we can exit the program and we'll save it there. Remember, save regularly. And now we're actually going to go into the details of some of these subroutines. So we're going to activate game settings, and we're going to go to the game settings doodah file, and we're going to type in some of our settings. I may have forgotten one. Yes, I did. There's one subroutine I forgot, and I'll explain this later. Go sub randomize ball, and I'll explain why randomize ball appears in the game settings but is called later on. The order of the program sequence and everything being called is important to make a note of. So we go to game settings, we'll worry about game settings first. Now we're going to set up several things. I know my game is set up as width of 1024. Now this isn't the same as the one you're getting set up. This is all compiler stuff, getting the settings ready. It doesn't actually get compiled into the main program as far as I'm aware. And because it occurred in the setup, I believe it's treated as a local variable to this particular thing. So it doesn't affect, it won't appear in the main program. I haven't actually experimented with this, I'm just assuming it. So if you want to test my theory, by all means do so. And if it's wrong, please comment on my YouTube channel and let me and others know. equals 600. So we're establishing the height of the program and the width of the program. So again, we're using it to netbook standards. So that's 1024 by 600. And now we're going to set up the speed of the ball. So ball.sx equals 8. So now we know what SX stands for. It stands for speed x, x-axis and y-axis. The x-axis goes from 0 to a positive number in this direction. So if this white area here was a game, then this upper corner here would be 0 along the x-axis, and this corner up here would be 1024. So anything, so 1 would go 1 pixel over, 100 would go 100 pixels over, 512 would be the middle of the screen, etc., etc. I'm also going to set up ball.sy equals 4. Now the reason they're not the same is because, again, this viewing area here is roughly the sort of shape we'll be getting. So you've got more pixels going this way than you have this way. If they were the same speed, then it will be going in a diagonal line. What I want it to do is go from the center of the screen towards the corner. I don't want it to be perfect, because if it's perfect, then we get a somewhat more predictable result than I want. So by doing it very roughly like this, it allows the ball to appear more random than it actually is. So ball.sx, now this is basically controlling the number of pixels the ball will move each cycle. So every cycle this ball will move 8 pixels. The reason that I've assigned it as a float is because a float can be applied to pixel coordinates. For instance, because integers are rounded up or down, basically if it's if it's 8.05, then it will be rounded down to 8, and it will move 8 pixels, I think. No, because it is being added to, because we're dealing with variables here, the actual position of the object might not be 8, but because we're keeping track of the movement, it will basically get added to the ball position, and as it increases, then it will basically take its effect throughout the whole program. You'll see what I mean as the program goes on. It's a little bit soon to be explaining that, to be honest. The only other setting I need to set up here is going to be mFlag equals 0. And again, I'll explain that when I actually come to it. Now, we've basically typed all that in. We've activated the subroutine. And now if we quickly compile it, just see if we've got any compile errors. Yes, we have. Variable ball does not exist at line 4 inside game settings. So let's have a look at where we declared it all. And yes, it appears I haven't declared ball, so ball should be, well, it doesn't matter where it goes really. So if we put in ball as obj, so this is why it's important to keep compiling and testing your code. If you do it all in one go, you're going to get yourself in a horrible mess. So, compile regularly to see where you screwed up, and then it's relatively easy to fix. So as you can see, this program is currently working quite well. So that's now all worked correctly. Now what we need to do is go on to the environment setup, so we're going to go back to game settings. In fact, actually, we're going to activate this here. And we're going to go to game settings and environment setup, and we're going to type in set virtual resolution, open bracket, width, comma, height. Now what this basically does is it creates, well, as the command says, it creates a virtual resolution. Now, in my previous tutorial, I used the percentage system to establish where to put things. Here, we're actually going to be using a fixed resolution and allowing AGK itself to automatically scale and convert everything to any platform. So if this goes onto a smaller mobile device, it will automatically scale everything down, keeping the same aspect ratio, so the graphics will still look crisp, but they all still look good, and and then maintain the same coordinate system here. So all the logic and instructions and everything we write into this code will basically be scaled down and ported to another platform with a smaller screen without you having to change a thing. So this virtual resolution business is very useful, especially when you want to be quite specific with your ball. The percentage system is fine. But I prefer to use fixed resolution and know where I am, because that's what I'm used to working with Dart Basic Professional. Now the other thing we need to set up is set display aspect. So set display aspect. So this is the aspect ratio of the screen. Now in order to work this out, all you got to do is height divided by width. Or was it the other way around? Yes, height divided by width. So height divided by width, this will be around 0.58 something something something. So basically what this basically does is maintain the aspect ratio of the screen as well. Because we've set it to a specific resolution, we're now setting a specific aspect ratio. What this basically means is if I ported this onto the iPad, as it is now, you get black areas along the bottom and across the top of the screen, because it's focused on keeping the image quality correct. It's not stretching anything, it's not altering the proportions of anything. All it's doing is treating it like a video. If you opened up a video on your iPad, even though it's not a 16:9 screen, all it does is put in black areas at the top and bottom of the video, and this software basically does exactly the same thing. Having said that, nothing's stopping me coming back later and adjusting the resolution and stuff. This game is programmed in such a way, because I put in height and width here, I'm going to be repeatedly referring to these. This will allow me to detect the edge of the screen and all sorts of things. You'll see me using it all the time. So the next one we're going to set up is set sync rate, and that's going to be 30,0. Now the 30 refers to the number of frames per second. 0 refers to the mode of it. Now 0, basically what happens is that it slows the program down to 30 frames a second, because we're only dealing with sprites. An iPad, for instance, would have a lot more processing power than a low-end Bada phone. So basically what happens is all those extra cycles and stuff, that basically gets converted to sleep time, so it's not constantly thrashing the processor. If you set it to 1, it's an incredibly accurate frame rate to produce, so you know it's going to be 30 frames a second. By setting 0, it's kinder to the battery, so I recommend doing this if you're designing for mobile devices, which of course this software is ultimately designed for. So iPad, iPod, Amigo phone, which will be the N900 or N9, is it Nokia? Anyway, there's loads and loads of different devices out there. In order to save battery power, I wouldn't be so worried about maintaining the sync rate, definitely, but instead use this mode, use the sleep mode. It basically means it sleeps in between cycles when it's got nothing to do, so it doesn't use as much processing power. However, if you set it to 1, it will use a lot more processing power and drain your battery that much faster. So again, I recommend you use this setting. Yep, so we're going to compile here. We got no errors, so this is all working quite nicely. And we're going to save, of course. And then we're going to move on to our next one. So load music, nice and simple. So we're going to go into the media file this time. So we're going to go into media, and we're going to go to, well, we're going to create a new subroutine. So load music and return. And then in between there, it's going to be music.theme equals load music half bit.mp3, and we're also going to play music. So play music music.theme and 1. Now you'll notice that all we're basically doing here is we're assigning the ID of this music into here. So there are two ways of basically loading media. You can load music, you can give it a specific file ID, and you can go file name half-bit.mp3. You do need to be case sensitive, but I won't be compiling this, so I don't need to worry about it. So basically, rather than using that, we've put in a 1, and that will automatically be assigned as 1. Now, the other way of doing this, of course, would be music.theme equals 1, and then music.theme, which basically does exactly the same as we're doing here. So this new loading structure in AGK saves us a line of code and saves us a way of managing that. So we get rid of these lines here, and again go here, load music, compile the game. Speakers plugged in. There's no error message or anything. I know the music. Send up an error message. So that is working correctly. And what I need to do next is go to here, and we're going to load sounds. So again, we're going to go to media and load sounds. Now, it may seem a bit of a waste having whole subroutines for all this, but again, I intend on taking this program later on and developing it even further beyond, so there will be additional music and sounds and stuff as well. So this is pretty much the basic version, or the simplest version of the software I felt comfortable developing. So we're going to type in simply sound.ball equals load sound dot open bracket quote ball dot wave. And again, if we go to our media folder, you'll see the files there. So you got that, and you got ball.wave, and because they're in the media folder, we don't need to add a file path. If I was going to put it into a music folder, then I'll type in music slash, or is it that one? Anyway, it's one of those slashes, and that will then go into the music subfolder of the media folder. But I'm just going to leave it all in the media, again, for a program this size. There isn't so much that I need to worry about file management. So again, compile. Great. So that's working correctly as well. So we'll go back to main again. And next we want to load images. So again, we're going to go to media, and we're going to type in load images and return. And we're going to type in, well, there's going to be a whole bunch of them this time. So we're going to load them in exactly the same way as we did before. So background.img equals load image and background.jpg. Now, JPEG files do not have transparency, so don't use JPEG if you want your sprite to overlay anything else, because I'm just using the background. A JPEG will do. I do not need to worry about the alpha channel. And logo.img equals load image logo.png. Because this is going to overlay the background, we're going to need transparency. agk.img equals load image and legal.png. Oh no, so that should be agk. Pay attention, Daniel. So that's the agk logo. I think that's in capitals, actually. Yes, it is. So agk, and then it's legal.img equals load image legal.png. So all nice logical file names that it's easy to keep track of. For the most part, I just use lowercase. Tap.image equals load image tap.png, and court equals img. Sorry, court img equals load image. Just court.png. Ball.img equals load image. Ball.png. Pad.img equals load image. Pad.png. And last but not least, font.img equals load image. Font dark blue.png. And that's basically our image is loaded up. So again, we'll make sure that I've activated. Yep. Those images have loaded up checking that all the file names and details and stuff I checked it, I typed in was correct, and all the identifiers I used were correct as well. So now we're going to create sprites. This again will take place under the media file. Yep. So create sprites. This is the point where you're going to be able to start seeing things. Return, and basically we're going to type in background.spr, short for sprite, equals create sprite background.img. So we've got the number for background.img would be 1 probably, because it started off as 1. You know, it's the first one we loaded, so that's almost certainly 1. But instead of typing in 1 and having to actually know all that information, we simply refer to the object by name, which is a lot easier to remember. Logo.spr equals create sprite logo.img. Sure, you'll see the pattern. agk.spr equals create sprite agk.img. So all we're doing is we're assigning the images to our sprites, to our sprite objects. So legal.spr. Remember, you can assign new images to a sprite at any time you wish. So these are by no means fixed. Legal, yes, legal.img. Tap.spr equals create sprite tap.img. Court, yep, court.spr equals create sprite court.img. Ball.spr equals create sprite ball.img. Don't need to put a space after it, it's just I started off that way, so I continued. Create sprite pad.img, and that's basically all our sprites created. So in theory we should be able to see these sprites appear in a very higgledy-piggledy mess. Big mess and and it's now. So now we're going to set up these sprite properties, which will basically position everything in the way we want. And again, I'm going to put this under the media folder, and we're going to give that the name set sprite properties. And we're now going to start relying more and more on data we get from the sprites. So the first thing we're going to do is set up the AGK logo, so it appears in the lower right hand corner of the screen. So agk.w, equals get sprite width agk.spr, and agk.h equals get sprite width agk.spr. Oh, no, it should be height. My apologies. So, I mean, if we were doing this in any other way, we would have to go into the media folder, we would have to locate the file, which would be AGK, we would have to look at the properties here, which would be 128 by 128, and then we would have to type in agk.w equals 128. We don't need to do this, we just get the computer to look at the doodah for you and return the correct information. And what this basically does is return 128 for you. Now this basically means that you can replace any image of a different resolution and it will still come back with the correct data. So now we're going to set sprite offset and agk.spr, which is the identifier. So we are identifying the sprite by name, and we're now going to type in where am I? Okay, agk.w divided by 2 and agk.h divided by 2. So what we've basically done here is we've got the whole width and the whole height of the sprite in question. Then we set the sprite offset. Now the offset basically is finding the middle of the sprite. Sprites are initially drawn from the top left hand corner. So if I go into the media here and I load this up here, now the corner would be here. So if I specified a coordinate of 0, 0, it would draw the sprite from here right across. However, if I specified a position of 0, 0 with the offset, then it selects the middle. So you don't basically only get you'd only get a quarter of the sprite because everything else would be hidden. It would be drawing from here to here. So you'd have to offset it by 64 in order to get the whole thing drawn. Now what this basically does is means I can position it by the middle of the sprite, which I find easier. And that's basically it. So we've got the data, we've set the sprite offset, and now we're going to do the same for tap. Tap.w equals get sprite width tap.spr. Tap.h equals get sprite height. Tap.spr and set sprite offset, and that's going to be exactly the same again. It's going to be tap.spr, then tap.w divided by 2 and tap.h divided by 2. So we're setting the center point of the sprite there. The next one we need to set up is ball. So ball.w equals get, in fact if we copy that, ball.spr and ball.h equals height ball.spr and set sprite offset equals ball.spr comma ball.w divided by 2 and ball.h divided by 2 as well. And the final one we need to do is pad.w equals get sprite width pad.w pad.h equals get sprite height pad.w, do apologise, that should be SPR, and that should be SPR as well. And set sprite offset, pad.spr, pad.w divided by 2, and pad.h divided by 2. So we've now found the center point of all those sprites. Now whenever we use the command set sprite position by offset, we will then be positioning it by the middle of the sprite. So if we type in the command here, set sprite position by offset. Now you can type in one or two commands. Set sprite position or set sprite position by offset. Now the difference between these two is one draws from the corner, the offset will draw from whatever offset point you set. We set the center, so it will draw from the middle outwards. So again, if you positioned sprite if you set position sprite 0,0, then you would then draw from the corner outwards. If you did the same thing for set sprite offset, then you basically lose 3/4 of the image, because it'll then be drawing only one corner. It will be going from the center outwards. I'll show you what I mean in a minute, but for all these I'm going to be using set sprite offset. So agk.spr, comma width minus agk.w divided by 2 minus 5. So what I'm basically doing is describing the precise location I want it drawn to, based on the width. This basically means that if I change the resolution of the screen at any point, the image will still be positioned where I want in relation to it. So what I'm basically doing here is describing it to go across the width, which is going to be the x-axis. So it's going across the x-axis by width. Then it's subtracting half of itself, so it's moving half of it out, and then drawing, so it's going to be going from there to there, and then we're adding 5 as well, so we've got a little bit of white space around the edge of the actual sprite. So I think I can probably show you a demonstration quickly. I'll just put the other half of it in, so height minus agk.h divided by 2 minus 5. Don't need all those spaces in there. Now, if I'm right, I can just compile it as it is. I hope. No, I was wrong. I didn't understand the command line 45. So line 45 is get sprite offset. I've typed that in wrong, haven't I? What's going on there? Am I just not typing it incorrect? Oh, typed in get, not set. Right, obviously I'm getting tired. Okay, so let's compile that again. Okay, so remember that this logo is now in position. So he's drawing from the centre here. We've only got we've added 5 and we've done the same thing and it's given this position. Now, if I was going to select it without do exactly the same thing. No, it's only moved out. It's drawn from the corner. Half as much. These two here. put the by offset and compile here as well. And you'll see it's moved down quite significantly. We're putting the divide by 2 there. To be honest, I didn't really need to put all this code up there. It's just that I was so used to using it at that point that I was thinking in that way. So this is probably a more this is definitely a more complicated way of doing it, but it does demonstrate the difference between the two methods. So we'll quickly compile again, make sure it's in the right place. I have to type in all that to get the effect like that. I could have done it by set position sprite there, but again I was thinking in centers and I just found it easier to do it this way at the time. It's just how my weird brain works at some point. So anyway, we're going to do the same thing for the rest of it. Because I was working with tap and ball, which really do need to be positioned by the center for my purposes, then that's the way I did it. So set sprite, in fact we can just copy this. Whoops, I wish this key would work. There we go. And set position, so tap dot SPR, and this time we're going to go width divided by 2 and height divided by 2 as well. Sorry about that, my phone was on vibrate again. Anyway, where was I? Yeah, I think I just need an end bracket there, don't I? No, it's the second one, so I need to put in add 100. Set sprite position by offset, and we're going to position the ball this time. So ball.spr, width divided by 2 and height divided by 2. So we're just placing it dead center of the screen. And the final one is a pad, so set sprite position by offset, and that's going to be pad.spr, and position that a bit backwards, so pad, so that was width divided by 2 again, and height divided by 2, add, oh no, got that the wrong way around, should be add 200 there. There we go. And we're just going to compile that, make sure I've got the commands right and the positioning can be updated. Logo in the right place. So now that we've done that and we've established that it's looking okay, this is actually early code. You don't strictly need it here because we'll be updating the positions later, but it allows us to view the sprites separately, and while I was designing it, it gave me an idea of what I was doing. So this is a new command, set sprite visible, tap.spr is going to be 0. Set sprite visible. what this command basically does is, as you can imagine, it defines whether or not the sprite is visible or being drawn to the screen. If it's invisible, then you won't see it at all. So it's just not being drawn. It won't impact the frame rate as far as I'm aware. 0. Set sprite visible pad.spr, and we're going to hide that as well. And set sprite visible court.spr, 0. Again, you don't really need to worry about the spacing like I'm doing. I just like it to look neat. We'll compile that again. And you'll see the screen. So we don't actually need to hide the tap there at all. So we've got tap to in the menu code. So well, now we need to go to set up text. So we'll disable that, and we'll go to media, and we'll create another one called set up text. Now text very much behaves like sprites in this. They are treated as objects. Rather than in Dart Basic Professional, where you had to specify the coordinates all the time and draw it once per cycle, these objects are always on the screen, so you just place it on the screen, then you move it and do things with it afterwards, rather than having to put it on the screen for each cycle. So I need to type in here, it was quite a long one, and return. So just because that doesn't turn blue, don't worry, it's just because I haven't pressed return after it. It's just a little quirk of the IDE. So set text default font image. I keep typing test instead of text for some reason. So that's all one command, quite a long one. Now what this basically does is the bitmap we loaded up earlier with all our fonts. This one here, this is basically being loaded up as a font. So this is where we establish that this is going to be the default font for any text object positioned on the screen. So you can either load it up as set text font image, or you can set text default font image, and this basically means that we don't have to keep in type text set image all the time. It saves a bit of processing time, so this is just applied globally to any text from this point onwards. So font.img, and we're going to create several types of text here. So lost text equals create text. We're not actually going to fill that. All we're doing is we're creating these objects and setting their parameters. So set text size. Obviously this command will set the size of the text. Now 64 is going, it basically does it in pixels. So if you set 1, 2, 3 or 12, you're going to end up with some very small font. Now the images I've set up are 64 by 64, so that's as high as I want to go. Anything else would involve stretching the image, so you'll lose some of its quality. So lost text, there we go, and yes, so lost text, and we get a size. So we're applying this attribute to lost text, and we're also going to set the position. So set text oh no, I need to set the alignment first. Set text alignment, and that's going to be lost text, comma 1. Now, what this basically does is it centers the text to the coordinates you specified. So wherever you specify, that's where it's going to be centered. So if I now specify the center of the screen, i.e. width divided by 2, I know I will get a centered text in the middle of the screen. So I won't have to worry about the length of the text or perform any kind of calculations or work anything out. All I've got to do is set the alignment up and it will appear at the center point of wherever I specify. Set text position, lost text, width divided by 2, height divided by 2, minus 100. So we're finding the middle of the height of the screen and then we're moving it up by 100 units. And lost text 2 equals create text, then set text size, lost text 2, comma 64 was it? So maximum size at 64. Again, set text alignment. And set text position. And as you can imagine, this just sets the position of the text. So that's going to be lost text 2, comma width divided by 2, comma height. No, width divided by 2 minus 32, and height divided by 2 minus 40. Now I wonder why I've put that 32 in there. Let's have a look, shall we? Could not determine type of line 61. I didn't put a comma in there. Oh, I haven't put any text in there anyway, so I can't test. Anyway, I'm going to assume my positioning is right. It obviously produced the correct effect to get me to this point. So score text equals create text score 0. So we're actually giving it some text this time. Set text size, lost text, nope, sorry, score text, score text, and I want this half size, so 32, which look quite good. Set text alignment, score text, comma yeah, it's just 1 again, isn't it? And now we need to do the position, so set text position, set text position, and that's going to be score text, comma where is it? Score text, comma width divided by 4 and 0. I think that's it then. Now we're on to lives. So lives text equals create text lives 3 set text position lives text comma width divided by 4 times 3 add 32 over 0. That gave me quite a nice position last time. A lot of these numbers may seem a bit odd straight off, but they're the result of my experimentation and finding the position I found most attractive on the screen. So set text size lives text comma 32 and set text alignment lives text comma 1. So again we're going to center that. So remember, for the text alignment, 0 is left, 1 is center, 2 is right. So yeah, left 0, 1 center, 2 right. As far as I'm aware, there's no full justification on it. And so I don't think there is. I'll just have a quick look at the instructions. Yeah, if we have a look at the instructions, you've got 0 left, 1 center, 2 right. So there we go. And we'll just test that, make sure I've typed everything in correctly. Font up there as well. And in the position. There we go. And now we're going to hide it all. So set text visible. In the same way we did with sprites, it's text instead of sprites, but it's basically the same exact principle. So score text 0, set text visible, lives text 0, and set text visible, lost text comma 0. So again, if we compile that again, magically did. Though we didn't really need to do that for scored text, or was it live text, or oh yeah, lost text we didn't need to do it for. Technically we should do that for lost text 2 as well, just to keep the consistency up. But because there's nothing to display anyway, but it is still drawing as an object, so it probably saves a bit of processing power by hiding them properly. So next we're going to menu. We're going to create the menu. Yay! So we're going to a new one here, and we're going to type in menu and return. And we're going to type in set sprite visible. We don't actually need to type that in because I've already set the I think I have anyway. In there. It's a little bit of a change from the original source code, but never mind. Right, finish equals 0. Repeat until finish equals 1. Should be little letters. So this is your first taste of the repeat and until loop, unless of course you're experienced with other forms of BASIC. Basically, it works in the same way as doing loop. You, from the repeat, you then execute all the instructions in between until you hit loop. If the condition here isn't met, if that finish is still 0, then it will return to the repeat again. So it's literally repeating until finish equals 1. So quite self-explanatory, really. And we're going to put in a bunch of different decision-making commands here. So if if y is greater than -125, then y equals y minus 3, and set sprite position logo.spr 0, y. So what we're basically doing here is moving our sprite up by asking the question, is the y position of y greater, sorry, is y greater than -125? If it is, then we're basically moving it upwards by subtracting from the y value, then applying it to our set sprite position, which I've mistyped. And then we're going to go end if, and if I'm right, that will then create a nice animation. If I'd remembered to put sync in. So whoops there. So we could put sync before there. Try that again. The effect of the image going up with a bit nicer, I think. And as I'm the one writing it, it's only what I think that matters. So if get pointer pressed equals, oops, now I need the brackets, equals 1, then end if. So what we're basically doing here now, the get pointer pressed, what that basically means is whenever the mouse is clicked or the screen is tapped, you'll notice I've put tap rather than click on the screen. So if get pointer is pressed, so if the screen is tapped or the mouse button is clicked, then this if statement will activate. If statement, may not have gone through this with you already, but basically if is a question. So you're asking the question, is y greater than -125? Now, because y hasn't been created in this program so far, it starts off at a default value of 0. Now, if y is -125, then we go on. Then we execute these instructions until we hit end if. So that ends the end if condition. So we can put in as many commands as we like between those 2 points. But as soon as it hits that end if statement, then the whole if statement is over. So if is just a way of asking a question, and the more you'll read this, you'll get the feel for the pattern of what's going on. If not, again, you can go to the documentation, you can read all this, you can read all the principles and stuff. If you're having problems, then just go to the principles documentation, and you want to go into that's all mathematics, common statements. Somewhere in here, I'm sure. There we go. It's under the language. So if you go here and you go to language and you click on if, then it will give you an example of how it actually works in detail. So it's worth reading that as well if you're not familiar with that particular command. So assuming you are, we can carry. First of all, we're going to set finish to equal 1. So this means that once the mouse has been clicked, then the loop is over because it sets finish to 1. As soon as it hits finish there, that's it. This loop is over. Now, in the meantime, we're going to. Now, as soon as we click on it, if we have a quick compile, you see tap on the screen to start. So as soon as we tap on the screen, the program starts. Different things that has to do with that as well. So as soon as the mouse pointer is clicked, we're then going to set sprite visible. set sprite visible logo.spr, comma 0. And we're now hiding the logo sprite, so we'll just check that that's working. That logo now. So as you can see, that's what the set sprite visible does. When we set it to 0, again, if you want to show it, you set it to 1 instead. What else do we need to hide? Set sprite visible agk.spr, comma 0. Set sprite visible legal.spr, comma 0. Set sprite visible tap.spr, don't need that anymore. Set, in fact I can just copy this but save a little bit of time. If my bloody keys work. Right, there we go. Set sprite visible tap court.spr. Oh, he's .spr. Overthinking there. And we want court, then we want ball. Oh no, ball is going to be shown. So court now needs to be shown. So we've gone from all the stuff that's being invisible now to the stuff that needs to be visible. So as soon as I click on that, regular number brackets outside, because I did that. Sprite visible tap.spr, comma 1. We've got court.spr, comma 1. We've got ball.spr, comma 1. We've got pad.spr, comma 1. So these are all the game elements we're calling up here. And set, this is now the text, so set text visible. Score text, comma 1. Text visible. And we want lives text, comma 1. And set random seed timer. Now, set random seed basically sets the random number generator. Anyone who saw my last tutorial will have a rough idea what it does. Now, the reason I'm placing it here, those of you coming from my Dart Basic Professional tutorials will note that I've always put set random numbers. I've always used the randomize command at the very beginning of any program. That's because when the computer starts up, a normal desktop computer starts up, it's got a background process that's constantly counting in milliseconds. So getting a number to see your random number generator from that is very easy. However, these applications only start counting the timer from the time they're executed. So what we're doing here is we're relying on the variation in human response time. So each time I press the tap screen is going to be slightly different than the next time I tap it. So we're basically relying on the user's delay in, if they hit the button the same time, exactly the same millisecond after they started up the program each time, then basically they would get the same result each time. But because human mechanics isn't that accurate, you would only get it by luck. This basically allows us to randomize the seed in that way. So I certainly don't know of any other way of doing it. If anyone does, and again, please leave a comment, let me know. I'm always looking for ways to improve things. And that's basically it. So we set up the random number seed generator, and that's about it, I think. So we're going to compile, make sure all the code works. Move it up there. It's an animated thing. You have the music playing as well, but you can't hear it. So that should be interesting. It's because I selected 1 again, that's why. I'm an idiot. Let's try that again. And there we go. So now we set up we've got our pad there, we've got our ball, score, and save, and that's basically it for the menu function. We're now going to go into the main game, I think. No, we've got to randomize the ball first. So we want to randomize the starting position and direction of the ball, just to keep the player on their toes. And to do that, I think we need to go into settings again. Game settings, randomize ball. Yes, there we go. So game settings, randomize ball. So this is why this setting is occurring at the end of it, because we've only now run the set random seed. By doing that, we're getting a nice random effect put into our program. Ball.x equals random 50, width divided by 2 minus 50. Ball dot y equals random 50, height minus 50. X flag equals random 0, 1, and y flag equals random 0, 1. Now, the X and Y flag, if it's 0 there on X, then it goes towards the left, I believe. If it's 1, then the ball is heading towards the right. For Y, if the ball is 0, then it's heading upwards. If it's 1, then it's heading downwards. So that's what that is controlling, and I'll show you how that's actually managed soon. So we've just randomized the direction and the starting position of the ball. And rather than working directly on the sprites, what we're going to do is we're going to manipulate these numbers, then place the sprites where those numbers are. So all we're doing throughout this program now is using logic and mathematics to position the ball via coordinate systems, and then placing the ball at that coordinate, and then running certain checks and things along that basic premise. So we randomized that. Again, compile, make sure it all works. Yep. Good so far. Oh, it's thirsty work, this. And there we go. So now we're going to go into the actual do functions, or the main do loop. So we're actually going to go into the main loop. So wall detection. Don't need that anymore. So we're going to type in wall detection and return. And now when we say detection, what we're actually going to do is monitor the position of the ball, or rather the variable that the ball is positioned with. So if ball.x hash is greater than width, and end if, and a bunch of commands in there. So ball.sx minus oh no, sorry, equals ball.sx hash minus speed inc. Now I've just remembered that I didn't type in speed inc, so if we go back to game settings, there's 3 more variables I missed to type in last time. So speed inc equals 0.05 and score equals 0 and lives equals 3. So I should have set those up last time. Small fix, never mind. So we go back there. So what we're basically doing here is saying ball equals now should that be x or sx? Yes, it should be sx. Okay, so ball.sx, which is speed x, equals ball.speedx. I think it should be plus, not minus. Yeah, ball.x is greater than width, and ball.sx hash equals ball.sx hash add speed inc. So basically, if this is triggered, so if the ball goes above the width is 1024 pixels. So if the value of ball.x hash is ever greater than 1024, then this if statement is triggered. So then the ball detects that it's basically sped up, and we speed them up on both axes. So s equals ball.sy hash plus speed inc. So no matter what surface we hit, we're going to want to increase the speed of the ball, and that's basically what this is doing. Then x flag equals 0 and lives equals lives minus 1. Set text string lives text open bracket lives add string lives, and there we go. So 2 new commands here. Set text string basically alters the text of the object. Lives, and we're inserting the string lives, and we put in the plus sign, and str basically converts any integer or float variable into a string. If you just typed in lives, then you would get a crash because it's not the right type that needs to be inserted. And we also want to play sound, so play sound sound.ball. So there we go. So we've increased the speed of, sorry, as soon as the ball impacts this wall over here, because this along the x-axis, remember x goes from left to right, so as soon as you hit 1024, then it triggers all this. So we've increased the speed, we've set the flag to 0, we've reduced the number of lives because it's hit this wall. As soon as you hit this wall, you lose lives. We've set the text string on your lives to update the change. We've set the X flag, which is something that controls another section which controls the position of the ball, and we're playing a sound to boot as well. So if we go on the next one, if ball dot y is greater than height, and if now these will be far simpler. Now this is going to be a common thing among all of them, so I'll copy that and paste it in there, because no matter what wall or object you hit, you always want the speed to increase. That's one of the rules of the game. X flag. Oh no, it should be Y flag, shouldn't it? Yes, we're dealing with Y here. So Y flag equals 0. And play sound dot ball. And the next one is if ball dot x hash is less than 0, so we're checking this side now. If it's less than 0, then basically we've hit the wall we want to hit. So and if so ball, oh yeah, we need to paste that in there, and we need to go x flag equals 1. Now you'll notice last time the wall got hit, it got set to 0. Now flag has been set to 1, so it's now going to go in the other direction, and that will be courtesy of another area of the program. Now ball dot point equals 0. Play sound dot ball. Now the ball dot point is basically tracking whether or not the wall's been hit or the pad's been hit. If the pad has been hit, it will return a 1. If the wall has been hit, then it will return a 0. Now you will only score a point if you if you hit the ball with the pad, then it hits the wall, then it hits your pad again. So you can't just have the ball in your side of the screen and just bat it between the pad scoring points. It has to hit that wall and it has to come back at you before you score a point. So that's one way of stopping people from cheating or exploiting the code. And I believe the final one, yeah, if ball dot y is less than 0, then ball dot sx, oh, you just need to paste that in, y flag equals 1, and play sound dot ball. So there we go. So we've now set up a set of conditions where contact with any of the 4 walls and the rules pertaining to that contact have been obeyed. So we'll go through that again. If ball.x hash is greater than width, so if it hits this wall over here, then we increase the speed of the ball. We set the x flag to 0, so it goes in the other direction. We set text string, so we update the number of lives, and we also subtract 1 from our lives, and we play the ball sound to contact. Now, if it hits either of these, up and down, that's going to be along the y-axis, then we don't really need to do much of anything at all. So if ball.y is greater than height, which will be down here, then we increase the speed, we reverse the flag, and we play a sound. If the ball hits this wall, we mark that the wall's been hit, we play the sound, we change the X flag so it's going in the other direction, and we increase the speed. And again, we increase the speed, we change the flag, and we play the sound. And this is basically our collision detection just by checking the variables. We don't need to do anything pixel perfect. All we're doing here is we're checking whether or not it's exceeded a certain threshold. So next we're going to go into some actual collision detection. Though I should compile that first just to make sure it works. So we're going to go into collision detection. And we're going to ask a big question here. If get sprite collision ball.spr pad.spr comma equals 1. So basically this is now detecting a collision between the pad and our ball. So whenever our pad comes into contact with the ball, it will return a 1. Whenever it doesn't, it returns a 0. So this will only come into effect whenever those two objects come into contact with one another. And we need to ask another one. If x flag equals 1, then x flag equals 0, else x flag equals 1. So what we're basically doing here is we're checking if x flag equals 1. If it does, then we basically want to we want to reverse the direction of the ball. If it doesn't equal 1, then we need it to equal 1. So we're basically reversing the direction of our ball there. So ball dot, that's going to be another speed increase. So as soon as we hit the pad, we're going to introduce another speed increase. And that should be tabbed up, really. No, it shouldn't, because it's not. Sorry, excuse me, mumbling to myself. It's only a sign of insanity. So ball.flag equals 0. So what we're basically doing here is I've left out a whole instruction set there, haven't I? My apologies. Right, if ball.flag equals 1, then we execute this set of instructions. So that makes more sense. So if ball.flag equals 1, then we're going to set it as 0 if there's a collision. And that's basically to prevent any kind of ricocheting inside the pad, because if your pad is in contact with the ball, then it'll just keep reversing direction all the time, and you'll get some very weird effects. So by keeping track of the ball flag in this way, we're basically telling the program that it can only be executed providing the ball has left the pad, so it's left the pad area. So only once the ball has ceased making contact with your pad will this instruction ever be continued again. So while it's in contact with the pad, ball.flag will always equal 0, and that means that this won't be triggered anymore. This, on the next cycle, this whole cycle of all these commands will basically be ignored. So if ball.point equals 0, and if score equals score add 1, ball.point equals 1. So if the ball comes into contact with the pad and its flag at point is 0, then we basically increase the score by 1, because it'll only hit 0 once it hits this wall over here, which was basically set up here. You'll see once it's hit this wall, the ball is set to 0. Then up here, because it's set to 0 and it's hit the pad, then we know it's hit this wall, so next time it hits the pad we basically gain a point. So ball point equals 1, and that basically tells us that the pad's been tapped, and we go back here and it won't so basically if this is still 1 when it comes to hitting the pad again, then this little section won't be triggered at all. So it will only ever return a value of 0 once it's hit this wall. It will never return a value of 0 if it hits the pad. So if you're just bouncing it between the pad, then it's not going to work. So set text string score text comma score add string. So again, we're converting a integer into a string, in this case a score. So we've increased the score by 1. Now we're updating the text element that deals with the score. And finally we want to play the sound. So play sound. Sound.ball. And now we need to type in if get sprite collision ball.spr and pad.spr equals 0, then ball.flag equals 1. So I hope that makes more sense now. So basically what we're saying is if the oh, that should be collision. That should be get, not set. Okay, so if get sprite collision ball comma dot pad.spr, so it's basically asking if there's a collision between those two sprites. If there isn't one, then ball flag is set to 1, and that means the next cycle this will be triggered as soon as the ball comes in contact. So providing this is set to 1, then ball flag is set to 1, then we check for the collision between the ball and the pad. If there is one, then we execute the code that says if x flag equals 1, then x flag equals 0, else x flag equals 1. So we're basically saying reverse it if it equals 1. If it doesn't, then x flag still equals 1. Ball.sx hash equals ball.sx hash add speed increase, and ball.sy so basically we just increase the speed of the ball there. Here we monitor whether or not it's impacted this wall over there. If the ball point equals 0, then we and it's hit the pad, then basically we get a score of 1, and we set the ball point to 0, and that will only be reset once it hits this wall again, and then we update our text, and that's basically the collision detection. So all pretty simple stuff. We'll save our doodah there, and again we're going to compile, make sure there's no errors. There we go. So label does not exist at line 50, so I've probably typed it in wrong, so I'll copy that. Whoops. What did I type in there? Don't know what I typed in there. Oh, detect collision, not collision detection. That's what I reversed it, did I? Okay. No errors. So we're getting there. We've only got 3 more to go, and we've basically got a game that's fully working. So the next one is update pad. So this will be the first interaction we really get. So I'll just copy that just to... Don't know why that doesn't give me copy there, but never mind. Copy and main loop. And... whoops. There we go. So update pad is relatively simple. Pad.x hash equals get position x pad dot get position x. Or is it pointer x? Ah, my apologies. Get pointer x and xy equals get pointer y. And what else do we need to do then? set sprite position by offset, and pad.spr, comma, pad.hash and pad.yhash. Type it in there eventually, and right, I'll just show you what this does very quickly. Sprite is what else is there? Set sprite, offset sprite, pad. Oh yes, I want to limit it. So if pad.x hash is less than width divided by 2, then pad.x hash equals width divided by 2. So what we're basically saying there is if pad is on the side of the screen, is on the left side of the screen, then we're going to move it to the center of the screen, but it has free motion along the right side of the screen. So it's basically saying if pad is below 512, then pad equals 512, so you can never go past the 512 barrier. And if we compile that now, despite my mouse that's basically the pad updated. So that was a nice simple one. And now we're going to update the ball. Yay! So update ball, return, and this is where we check the X flags. It's a pretty simple one. So if X flag equals 0, else and end if. Now else provides an alternative. If it's ever not 0, then the else sequence will be triggered. So we're going to type in ball dot x hash equals ball dot x hash minus ball.sx hash. So we're basically adjusting the x position of the ball by the currently set speed, which has been determined by the number of surfaces you're bouncing off. And we basically do the reverse for an else. So if the flag is 1, then we want to go in the other direction. So instead of subtracting, we're adding. So ball.x hash equals ball.x hash add ball.sx hash. And now we're going to do the same, exactly the same thing for the y. So we're just going to copy this, and we're just going to go y, 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 and Y. And we're going to finish off by going set sprite position by offset, because it's what I always do. Ball.spr, ball.x hash, comma ball.y hash. So this is now positioning it to the coordinates we set up here by subtracting the speed or adding the speed as required. So in theory, providing I don't embarrass myself too much now, so we've now got impacts on condition. So this is probably one of the longest ones here actually. And now we're going to do lives check. So we go down here and we enable lives check. Lives check. Return. If lives is less than 0, then restart equals 0. Is that right? Yes. So it should be an end if there. Okay. Repeat until restart equals 1. Set text sorry about that, phone went off again. Right, where was I? So I was in the repeat and until, so set text visible, lost text, comma 1, set text string, set text string as lose text, game over. Set text string lost text 2 and final score add str score. There we go. We also need to repeat this for set text 2. If get pointer pressed equals 1, then restart equals 1. Now I don't actually need all this here. I can actually put this here, I believe. So all I need to do is sync here. Save us setting the same properties over and over and over again. So what we're basically doing is as soon as lives hit 0, then we set restart to 0. We're activating lost text 1 and lost text 2. We're assigning them strings with an updated score. Repeat, if the pointer is pressed, then 1, then restart equals 1, and that's what exits the loop. Sync basically continues the program cycling. Updating the display, and then if restart equals 1, so basically once we exit that loop there and we've broken 3 of that loop, I'll put a little space there to isolate it. We then go on to some reset data. So ball.sx, actually we can copy that as part of the original settings. So we need to restore the original settings. We also need to take these settings as well. And I just noticed one other thing I didn't do. I didn't set the tap to activate either. So set sprite visible tap.spr, 1, to actually indicate that you need to tap the screen. And now of course we need to take all this and I'll put it down there, then copy this and paste it down here. And we can hide all this, we won't need to see it for the next game. And unless I'm very much mistaken, that should do the trick. So let's compile it, see what horrible errors appear. So basically set string, set text string, lives text, lives 3, set text string, score text, score 0. And hopefully keep your fingers crossed. if you create any award-winning games, you'll get a free copy as well. So thanks for watching, and I hope to see you back in